Yeah, so I'm just comparing lifting like with good form to lifting with bad form.
Okay.
And then like the difference in the muscle force that you have to produce to actually move the weight off the floor.
The initial.
Yeah, and then I'll basically make an argument about, lifting consistently with why lifting consistently with bad form would put you at a much higher risk for injury than lifting consistently with good form.
Essentially, how many duty cycles the spine has, so we'll close it up.
Yeah. Exactly.
Do you guys have your presentation on the laptop?
Yes.
Do you want to?
Send it out, we're gonna send it to.
Yeah. I do have a flash drive if you want to use that. Do you want to come up and test it real quick just to make sure that it looks okay? So the first group today is virtual, so they're just going to share their screen. I want to check to make sure that
It's only 130 seconds. No. We did ours on Google Slides.
Oh yeah, if you want to just log in from the console there, because otherwise it's hard to share the screen. Okay, yeah, if you want to just okay, let's do that.
Professor, there is Microsoft Word on all these computers, right?
Yes.
Okay,
Yeah.
because I did mine on PowerPoint, PowerPoint slides.
Okay. Yeah. PowerPoint works fine. Yeah, there's Microsoft Office on all these guys.
Oh, okay, so just like around right there. Okay, cool.
If you don't have animations though, you could turn into a PDF and then it'll be really stable from there.
You did everything in the last.
Yeah, I don't know if engineers really do all that animation stuff. So I
Yeah,
just-
usually they don't.
Yeah, so I just made it look a little bit pretty on like the slide design, and then I was just like, all right, I think that's good enough.
Honestly, for me, like as long as it gets the institution across, then it doesn't need any.
Yeah, that's what I figured. I was always like a very black and white kind of guy.
Yeah, same here.
Like I was always just like, okay, like this looks fine, and then I would always, but I would always lose points because they're like, you didn't put any effort into the PowerPoint.
I always hated it because I always felt like it's a distraction. Like you're presenting to get some information across.
Yeah, definitely, but like, for this, it's like much more like, okay, here's the facts, but when I was doing it before, it was like, I guess they expected like a little bit more finesse and like making it interesting. I think it definitely, like, you can see that pronounced in like the type of writing style that we use between disciplines too.
Oh yeah,
Like in
yeah, for sure.
anthropology, like you're expected to use a little bit more, flowery language,
Mhm.
you're explaining like social concepts. Where it's like for us, we're just like, all right, does it fail? Does it not? This is the mesh I used to do it. and
Right.
This is what happened when I ran the analysis.
Exactly.
And yeah, that difference really like, it's evident in the way that people present their information and stuff like that.
Yeah. We only have 2 presentations today, so we'll probably end pretty early. Everyone else is signed up for Wednesday.
Well, we couldn't get to Wednesday because everybody did this.
Yeah, you guys present today and then you're done with it. You don't have to worry about it the rest of the week. Yeah. Wait a second.
Yeah, or I think you said we covered.
Wait a second.
Zoom on Wednesday.
Oh yeah. In Zoom. I'm having everyone present from this computer here, and so you can view it on Zoom or
Okay.
yeah. Because some groups are presenting virtually too. So. Yeah. It's 354.
How are you doing, Professor?
All right, I see Fee, I see Keith. Which one of you guys has the slide for your guys' presentation today?
I have this. I do.
Or does Fernando have it? No, I can't. All right, let me turn up the volume here. The volume on the lectern is a little bit low.
Hello, hello.
All right, try again.
Can you hear me,
Oh.
Professor?
This would help too.
Hello.
Yeah, there we go.
Okay.
Okay, sweet.
Now I can hear you.
Fee, you have them, right?
Yeah, I got it.
Okay.
Okay,
So if you can let me share the screen, everything should be working out on my end.
okay, yeah, it's enabled, so you guys can go ahead and share.
Okay.
And I think Fernando's
We didn't know.
coming as well, right?
Yeah, he will. I'm sure. It's not even time for class yet, so he's probably taking a bit of a time. No worry.
Actually, since we have time today, let's spend the first 10 minutes today doing the SOQs, because I want to make sure that you guys do them, and then we'll get into the presentations after that.
Okay, no worries.
And Professor, you're doing the earthquake analysis lesson today in 540, right?
Yes. Yeah. We'll learn how to do harmonic response, just in general, and then I think we can meet individually, so I can show you how to do it with earthquakes. But
Okay.
I'm doing it general just for anyone that wants to do it, and then earthquakes you have to set it up a little bit, very similar, but just a little bit differently from that.
Okay.
Yeah.
Perfect. So I definitely need to get started on that one.
Mhm.
Final, sure.
Yeah, you got some time for that one though. You got still 2 more weeks until it's due.
Yeah.
It's very similar to the midterm project too. So
Yeah, I'm definitely like not stressing about getting it done, but it's just those new concepts, it's gonna take me a little bit longer to implement.
sure, for
And
sure.
I do have that controls final next week,
What day is that final?
14th.
14th. Okay.
So yeah, I don't want to be in a situation where, like, because I'm getting a lot of analysis done, like for the paper with the presentation. So I'll have basically like probably a little bit over 1/3, because I'll have a lot of the important training concepts I want to talk about and then the mechanical analysis.
Mhm.
But I don't want to be in a situation where I'm like struggling to balance 540 and then biomechanics and then 540 and then biomechanics.
For sure.
So I want to try to get that a lot of that
Mhm.
quicker.
All right, it's 4 o'clock, so let's go ahead and get started. Good afternoon, everyone. Welcome to the final week of class. So how's everyone feeling today? And good. All right, so we have final presentations lined up all this week. And so most of the presentations are actually going to be on Wednesday. So we actually only have 2 presentations today. So we do have a bit of time. And so I do want to do a little bit of bookkeeping, for this class, since we have the opportunity right now. So first of all, I do want to make an announcement for Wednesday. There was a little bit of a mix-up in terms of people signing up for multiple slots on Wednesday, and so we are going to start a little bit earlier on Wednesday. And so I'm going to have the first group go at 3:45 on Wednesday. And so I understand that not everyone can make it at that time because you probably have other classes before this, but it will be recorded. And so if you are able to come by 3:45 on Wednesday. Then the first group will go then, but then after that, we're gonna start firing off the other groups. So come when you can, but then if you come early just to see that first group, that would be great. Okay. All right. Second thing I want to talk about today is SOQs. Okay. So it's the end of the semester, so it's time to fill out evaluations for this class. Okay. So SOQs are always really important to me. Whenever I get my SOQs, I always go and read through every single comment. But for this class, it's especially going to be important because this is the first time we've offered this class. This is the first time I've taught this class. And actually, I was kind of making changes and adjustments to this class kind of in real time. And so if you saw what was proposed in the syllabus and what was on the course website versus where we actually went in this class, it was actually very different. A lot of it was based on what I felt was working, what I felt wasn't working, and what your guys' interest was too. So, I know it wasn't the most ideal class. It was very kind of disorganized at times. But that's why I'm really relying on your SOQs to tell me, what worked and what didn't work in this class. Okay. And so please go fill out the SOQs. I'm going to go step out, after I give my little spiel right now, I'm going to step out for about 10 minutes to let you do it. And so if you are joining on Zoom, you can just access the SOQs through your computer. Okay. And so I believe you do it through from your My Fullerton website. And so you go to my.fullerton.edu, and then there's a way for you to access your SOQs there. You probably have gotten a couple dozen emails about it recently as well. Okay. But anyway, like I was saying, the SOQs are important because that's the main method of feedback that we as instructors get on how to improve our classes, right? So we've just spent about 15 weeks of me giving you guys feedback on how to learn biomechanics. But for me, the way I learned how to be a better instructor, the way I learned how to better serve your students is through those SOQs. So it's really important for me to you guys to go do the SOQs first of all, and to give me as honest feedback as you can. Okay. I always tell everyone every year that I grew up in an age of people telling me all sorts of vulgar things online. So, you can be as honest with me as you can. So I've had people curse me out on the SOQs, and, honestly, those were some of the most helpful feedbacks that I've gotten, because they told me, very passionately about what didn't work in the class. And I take that very seriously. And so please go to do the SOQs, and, and please give me your most honest feedback about the class, because that's the only way that I get better at my job. Okay. All right. And so I'm going to go step out for about 10 minutes. To give you guys time to do the SOQs, because legally I can't be in the room while you guys are doing it. And then when I come back from that about maybe 4:15, then we'll start with our first presentation group for today. Okay. All right. So I'm gonna step out, and then you guys can go ahead and do that. And for the people that are coming in late, let me go ahead and do this. Please, no. Yeah. Red. Okay. Please do SOQ. Okay, BRB. Okay. All right, so I'll be back 4:15. Okay. Okay, I'm back. So if you guys did your SOQs, right? Okay, so let's go ahead and start with our presentation. So the first presentation that we have today is about MMA biomechanics, and so that's Fee, Keith, and Fernando. So I know you guys were here beforehand, so you guys can go ahead and share your screen, and then you can start whenever you're ready. Okay. Great. Can you guys do a mic check real quick?
Can you hear me?
Yep.
Hello?
Yes.
Okay,
Awesome.
yeah, I can hear all of you. Okay, yeah, whenever you guys are ready.
Okay.
All right. Hi, class. I'd like to present to you our MMA biomechanics subject presented by Finuan, Keith, McKinley, and myself, Fernando Villa. Our first fighting style is kickboxing, which is a sport relating to full contact toward an opponent with a kick or a punch. Similar to Muay Thai, but in Muay Thai, they are allowed to use their knees and elbows, while in kickboxing, they're not. Kickboxing does involve striking and kicking on an opponent above the waist, but there's no clinging or grappling toward the opponent. And even though knees aren't allowed to be used, they can be used to defend themselves. And its relation to biomechanics is its dynamic analysis on how fast a fighter can move their limb to hit the opponent and how much of their body is used to add momentum. Our first analysis we want to do is a roundhouse kick, which is a kick that requires the fighter to lean to their side while lifting their leg and having flexion to their knee to prepare for the kick. The kick itself is a knee extension, which will only rotate the lower leg and the foot to impact the opponent. Some parameters of a leg. So M1 is the lower leg, like the shin part of the leg, and M2 is the foot itself. So L1, which is about like 0.43 meters long, a foot is about only 0.254 meters long. For the shin or the calf portion, it's 4.75 kilograms, and the foot itself just 1.43. And studies show that a knee extension does about 28.4 radians per second while in rotation. And here are the calculations to impact force that an opponent will receive. So here we do velocity. We need to find velocity based on the radians given. And since we do only consider that the lower leg will be turned in the kick, we only add the distance of the lower leg and the foot, which is 0.43 added by 0.177 meters times the radiant, which would give us 17.3 meters per second. From there, we could find the momentum, which is just the mass of the lower leg plus the foot, which would give us 106.9 kilograms meters per second. And here we're assuming that the opponent would have their head stiffened up, which would give us a contact area of 0.02 seconds. Therefore, we use the force impact equation to find the amount of force the opponent's head will receive. And since we assume the head is stiffened, we assume the momentum of the head is 0 since they're not moving. And here we just divided by the impact or contact area, and will give us 534.5 newtons to the kick. Some discussion about kickboxing is a roundhouse kick only the lower leg is rotated to land the kick on the opponent, and it may not do much damage, but the purpose of the kick is to receive points when landed. And in order to do more damage, a larger reaction force is needed. A different kick has to be executed, such as the spinning back kick, which is what we see here on the image to the right. And the kick involves a whole leg in rotation with the body on the opposite side of a pivot point. That pivot point is the lower leg, which is planted on the ground, providing the base support for balance. And since the kick does involve more mass in the rotation and longer radius, the momentum will be greater, which will require a larger force impulse to stop the kick, meaning the opponent will receive a larger, more damage. Some training done in kickboxing are just basic compound exercises such as lunges, squats, deadlifts, etc. They mostly train the lower extremities because they want to increase force they can exert in a kick. This is done by increasing the strength in quads and hamstrings, which will allow the fighter to move their leg faster, which will increase their momentum of the kick. And increasing these muscles will also increase their mass, also contributing to the momentum. And they don't just do like regular like muscle lifts. They also do basic training like punching, kicking, so they can better the combinations in a fight. Typical injuries we see in the kickboxing is hamstring strains, ankle ligament strains, knee collateral ligament sprains, and most of these happen during training due to overusage of continuous movement. You rarely see these happening in regular fights, like actual fight. And stretching is done to lower the probability, but there's no way to avoid them.
Hello, class. My name is Keith McKinney, and I'm going over the martial art of jujitsu. So jujitsu is a grappling martial art that is primarily practiced on the ground. This martial art was designed so that a person who is smaller and weaker could have a fighting chance against an opponent with a larger frame who is stronger. The reason this is possible is that a person who practices jujitsu has knowledge of how to manipulate their opponent's weights and joints, leveraging their own body against the opponent's. This would allow them to set up a position in which the opponent must either submit or face injuries, such as dislocations, hyperextensions, broken bones, or cut off circulation of air or blood to different parts of the body. One of the founders of Brazilian Jiu-Jitsu, Helio Gracie, had a pretty frail physique. So he had to come up with different techniques that would work for his body type and emphasize leverage and timing over speed and strength. So before we get into the biomechanical analysis of an arm bar, I want to go over the process of an arm bar. The first step is to supinate the opponent's wrist so the palm is faced up. And then the second step, you want to position your legs over your opponent's head and upper body torso while having their arms between your legs. And you also want to adduct your knees together to prevent your opponent from escaping. And then step 3 is to extend the opponent's arm by controlling their arm while leaning back and pushing down with your legs. And step 4 is to apply force in the superior direction by extending your hips while keeping control of the opponent's arm and wrist to your body. So here we have our free body diagram. Here you can see all the different forces acting on your opponent's arm. So we have the fixed upper arm on the left-hand side, and then the green dot is the elbow joint, and then on the right-hand side you have the lower arm, which is where most of the forces are acting. We have our force from our hands holding the body or holding the arm to our body, which I turned into an equivalent force, and then the weight of the lower arm, and the force from the hips on the elbow joint, as well as the force from the muscle trying to keep the arm in equilibrium to prevent it from hyperextending. And then also we have our reaction forces in red. Okay. Next slide. So here on the left-hand side, we have our given values and unknown values. So we're going to be solving for our reaction forces in the X direction and Y direction, and the force of the muscle required to keep the arm in equilibrium. So I took the moment around J, which is the elbow, the green part, and set that to 0. And then I found the equation for it, which was force times distance. So force of the muscle, or the component force of the muscle times the distance away from the elbow, and then subtract that by the weight of the lower arm, and then times the distance of that, which is roughly half of the distance of the lower arm. and then subtract the force equivalent from your hands times the distance away from the elbow, and then rearrange the equation so that the force of the muscle, or we're solving for the force of the muscle, and then plug in our given values into that equation. And then we end up with the force of the muscle equaling 4,675 newtons, which sounds like a very high force. Moving on to summing the forces in the X and Y direction to solve for the reaction forces. I set the sum of the forces in the X direction equals 0. And in this case, there was only 2. We have our reaction force in the X direction, as well as our component force from the muscle in the X direction. And so our reaction force after we plug in our numbers in the X direction ends up being 4,048.66 newtons. And then I did basically the same thing in the Y direction, plugged in the equation and ended up with a negative number. So a negative 2,517.5 newtons. So the reaction force in the Y direction is pointing down, like opposite of the force of the hips. Okay, so if an arm bar is being performed and the force required to keep the arm in equilibrium is less than the forces applied to the elbow, the arm will hyperextend. So if hyperextension occurs, it can lead to ligament strain or ruptures. If force continues, the ulna can become dislocated from the humerus. Muscle tears don't usually happen, but muscles may become strained. Bone bruises and microfractures of the distal humerus and the elbow can occur as well.
Hi guys, my name is V. So the martial art I decided to go with is Muay Thai. So another name for Muay Thai is called the Art of 8 Limbs because of the usage of both hands, elbows, knees, and legs. As such, it will use both the upper and lower extremities, unlike kickboxing, which focus more on the lower extremities and just a bit of the upper extremities. And so the origin of Muay Thai stems from Thailand during the Sukhothai dynasty around the 13th century. During that time, there were lots of warfare. And so in order to defend themselves, the kingdom developed this martial arts style in order to defend itself from neighboring kingdoms. And because of its usage during warfare, there are lethal techniques such as elbow to the shin or knee to the liver, which would usually make someone pass out if that's inflicted on them perfectly. And so the Muay Thai did not become a national sport until the era of King Narai. And during that time, they basically had a ring, and in order for the fighters to compete against each other, the Muay Thai costume usually is a headband called mongkon, which was a symbol of respect and loyalty, and that was only given to them after they have proven themselves. It was like an honor, for them to receive a headband called headband like that. And the armband called Pa Pra Chiat was used to boost the fighter's confidence. So for my analysis, I decided to do a comparison between Muay Thai kick and a karate kick. And so the karate kick focused more on the instep, as you can see from the picture over here. And so since it focused only on the instep, I decided to just estimate the mass of it to be about 2 kilograms. And for the time was like 0.5 seconds, which is basically from the leg being lifted up from the ground to the sandbag. And the distance was about 1.32 meters. And so after the calculation, the force came out to be about 10.57 newtons. For Muay Thai kick, it's focused more on the shin of the leg, as such, because the shin is a bigger area. It got a bigger area of impact. It also got a bigger weight, and so I estimate it to be around like 10 kilograms. and the time it took was 1 second, which is about 0.5 seconds greater than the karate kick. And the distance was of 1.22 meters. And so the force became 12.19 newtons, which is slightly greater than the force from the karate kick. And so the reason why the Muay Thai kicks is a bit slower as compared to the karate kick is because the kick usually is more of an open hip, and so it requires a wider rotation. And so the knee usually is used often, especially toward the liver. And for Muay Thai, the focus will be more on the offense than defense. And the training method revolves around cortical remodeling, which is basically you hitting a sandbag or something hard in order to cause microfractures on your bones. That will decrease the porosity to increase the bone strength. And over time, your bone would just be way harder than it used to be. Though injuries does happen often for Muay Thai martial artists, such as excessive training, which can cause like severe fracture to the bones. And the thing about Muay Thai though is that it's not very good for ground fighting, as it doesn't have any way to actually defend against someone who knows ground fighting really well.
In conclusion, MMA has many final styles, and these are just a few. Many do share similar strikes and kicks as they do derive from other styles, like kickboxing being born from techniques of Muay Thai, karate, and boxing. Jiu-Jitsu, on the other hand, was created far earlier than most fighting styles we know now, but all use biomechanics to optimize the player's performance or the fighter's performance. Like in kickboxing, fighters utilize the rotation of the body to add more force to their kick to increase the momentum. In jiu-jitsu, fighters leverage their own bodies to apply forces to their opponent's joint to force a submission. In Muay Thai, the fighters are able to handle different situations because of their 8 points of contact style. Each fighting style does require the fighter to train their physical strength and speed in order to exert greater force onto the opponent. But the information of biomechanics lets them know which strikes are more effective.
Okay, great.
Thank you.
All right, thanks, guys. I don't know if you heard, but yeah, there was clapping in the class. So
Louder. No, just kidding.
great job, guys. Thank you. Thank you for that. That was really
Thank
good.
you very much.
Okay, and so our next presentation is going to be about soccer biomechanics, and so we have Abraham, Victor, and Dupois. We're here in the class, and so they're going to come up and share their slides on here, and then present from there. Okay. All right, so you guys can get set up, and then whenever you guys are ready, you can start. Let me go ahead and log out. Share screen too. Okay.
Good afternoon, everybody. I'm Abraham. This is my partners, Victor and Gia. We're presenting today on the biomechanics of soccer, or otherwise known as football in the rest of the world. here's a little clip just for humor.
Over here, our national sport is... No, I can't say it.
Look, I know it feels weird, but just say, over here, our national sport is soccer. Just
Nope.
say the word soccer.
I can't.
But that's what they call it, though.
Over here, our national sport is...
Okay, so what is football or soccer? So it's the most popular sport around the world. The most anticipated football competition is the World Cup every 4 years. And the last one being in 2018 registered a total of 1 billion spectators for the final. Soccer is played with the teams of 11 versus 11 on the pitch. The pitch is the soccer field. And each player has their assigned position, which is whether on attack, midfield, defense, or the goalie. You can't use your hands to play the game, only your legs, feet, head, or your torso. The game is a total of 90 minutes with 45-minute halves. And there's a 15-minute break in between the halves where on average, a player can run up to 11 and 16 kilometers per match. And injuries are prone to happen from the fatigue of the games that the players go through. And oftentimes it's usually 3 games a week, which is where they play for the respective club in that league. Champions League if they're in Europe, and another tournament that they play.
So my name is Victor, and why is soccer important to biomechanics? Soccer contributes to the study of muscle, ligaments, and joint biomechanics as players are pushed to their limits week in and week out. The health of the players are concerned for the respective clubs. So some of the common injuries are ankle sprains, meniscus and ACL tears, MCL tears, concussions, and pulled hamstrings. So here's a picture on the left of the player's name is Pepe, plays for Real Madrid. And then on the right is Antoine Griezmann. He plays for Atletico Madrid at the time. So here we see the player lunging at the white, lunging into the red. And eventually the contact is made on the knee where unfortunately the red player suffers an MCL injury. So then a little bit of background on some of the ligaments and injuries. So lower extremities of the body consist of bones, muscles, and ligaments. In football, the collateral knee ligaments are important for players, the MCL and ACL being the most injured by the players in soccer. The previous image was, like I said, the tackle resulted in, unfortunately, the MCL injury. So right here in the pictures, right here we see the torn ligament of an MCL on the left-hand side. And then on the right side, we see the picture of the ACL on the inside, and then the MCL on the far right. And the meniscus is attached to the ligament, so it's separated to a couple parts right here, 2 parts. And then also elaborate. So, and then the MCL injuries, so also important for players is how long they're injured, so their injury time, right? Because the clubs want their players to go back and stay healthy. So an MCL injury or medial collateral ligament injury occurs when the foot is planted and the knee side. And then they have different grades. So there's a grade 1, 2, and 3. Grade 3 being the most severe injury, and that injury can last from 4 to 8 weeks. And then let's take a closer look. The anterior cruciate ligament, or ACL, commonly known, is one of the most common injuries. The ACL injury is a result of cutting, pivoting of a single leg landing. The ACL is part of one of the 4 major ligaments that connect the femur to the tibia. And right here, we see another picture of what a regular ACL should look like on the inside. And then unfortunately a tear. This player right here from Barcelona, unfortunately suffers injuries from an ACL, and he's commonly injured. So unfortunately, he's been injured 3 to 4 times now. And he's only been in the team for about 18 months, 2 years. So it is unfortunate that he gets injured. This tends to happen to players that have high acceleration. So higher acceleration players tend to they use more of the pivoting, single landing, and cutting when they play. So depending on the player's game style is the type of injuries they get. And this player, unfortunately, is one of the fastest players on the pitch, and he suffers injuries from the ACL. And an ACL injury can last up to 6 months and another 3 months with physical therapy. So that's almost an entire season. So right here we have the example of the MCL static analysis. So that would be the player in the white, his name is Pepe, and then the player with red was Antoine Griezmann. So there's a traumatic blow to Griezmann's medial side of the knee right here. So right here we see what the simulation would be of the player, the defender, striking the MCL. The joint is about right here at the knee. And then we had to compute the moment about that joint right there. Here's some of the analysis. First, we did the moment about J, about the joint, and then we got the FM, and then we did the forces in the X, and then forces in the Y. So the results that we got from the reaction force at Griezmann's knee joint, J of X was 75.4 newtons, and J of Y was 1,203 newtons. Pass it on to Gia.
Yeah, and the shooting motion is also an important part of the soccer. And so for shooting, is a motion of putting all the power from the whole body into one spot. And it can be divided into 5 steps. The first step is approach, which comes to the soccer ball, usually with a 45 degrees angle. And the second step is the back wings. So the back wing is the legs is move back and to create more power. And the third one is the force production. So when your legs swing, it's produce a larger force production. It's the joint is from the major power is from the hip joint. And the third step, the fourth step is the foot contact. When your foot contact the ball and put all your force to the ball, and then the balls come out. And the last step is the follow through, and is which when the ball kick out and your whole body, what's the movement of your whole body, like move forward or just stay in the land. And the muscle involved in the shooting will mainly is the quadriceps, which is the red part, and the hip flexion is the main force for the power of the shooting. So here, this hip joint is the major power, and a perfect shooting will utilize all these muscles, which is vastus lateralis muscles, medial vastus muscle, and the soleus muscles, and the gluteus maximus. And but sometimes player, because the game is very competitive, so the player do not have a lot of time to use all these muscles. So the shooting power is different in different situations. And in order to get the maximum power to the soccer ball, the joint angle of the hip joint, knee joint, and the ankle joint needed to reach a proper range. The proper range is a range that will cause the player not injured by themselves, but also can reach to the maximum force. And the downswing is the speed of the lower leg can reach over 1,500 degrees per second, but without like an isolated knee extension cannot produce this speed. So just like I said in the last slides, the major power is from the hip joint. So the knee extensor only produce a little bit power. So the main function is to position the limb so that the energy can transfer from the energy transfer from the hip joint and to the knee extension, and then the knee extension can transfer the power to the foot, which can reach to the ball. The supporting leg is also very important in the soccer. So it's like a large brake force, which comes towards to your kicking legs, and it slow the forward motion of the body and absorb the force, stabilize the movement of the body. And we can see here when shooting, the supporting leg needed to bend in order to absorb the power. And here is a video of I make this video of shooting by myself. Wait. And it's a shooting. The first shooting, my supporting leg doesn't move. It stay on the ground, so the power of the ball are not that much. So this is the first kick. My supporting leg doesn't move. So my supporting leg doesn't move, and the ball's power is not that much, but it's much more accurate. And then the second shoots, I move my supporting legs after I shoot. So the brake force are not act on my body, so the ball can reach more power. And this also a simulation of I find. So this simulation software they use to check the shooting motion, and the supporting legs is stable the whole body, and so it's the supporting legs is acting a brake force. And I'm talking about the injuries of all the shooting, and the hamstrings strain injuries is a common injury that will occur during the shooting. And then when muscle cannot support the force being applied, it will happen instantly. It can also happen with repetitive movement over time. So as we said before, the shooting is with quadriceps, it produces a large force. And so the strain on your back of the leg, legs is needed to sustain a larger force. If you use too much power, and your hamstring strain will broken, and this the degree, and this the how serious the hamstring strain injury. The grade 1 is a little bit, and the grade 2 is like this, and grade 3 is the whole thing is just broken. So it can also happen with repetitive movement over time, like in a soccer game is very competitive. So players run a lot, and sometimes they will hurt their hamstring strain in the game. And to avoid getting this injury during a soccer game, the athletes need to stretch their legs very often before the game, so they can avoid these injuries. And here is an example of the shooting. This speed can reach to 200 kilometers per hour. And so the player named Paulinho, and he's the force that Paulinho produced will be around 1,139 Newton. So I just tested on the V equal to AT, which the 200 kilometer will transfer to 55.56 meter per second, and the time to reach the speed is 0.02 seconds, and so the acceleration will be around almost 3,000, and I use that to calculate the force will reach to 1,139 newtons, and then the soccer ball is usually 500 grams. And so the momentum force will be on the hip joint here, will be 1,139 Newton times the length of the femur, which is 0.4 meters, which will reach 555.6 Newton per meter. And the first motion, this one is the back wings, and that one, which is the force production, because the legs swing down to the middle of the edge, and so the FX will be the right legs, which was the kicking legs, and the supporting legs produce a brake force, which the F right minus F support will equal to 0, and just the weight of the body and minus the normal force to support the supporting legs. So for this section, we talk about linear dynamics, and in particular, we're going to focus on the player Cristiano Ronaldo, which he is known for his vertical ability to jump pretty high. Okay, and here's a short clip about his vertical ability being actually tested in a lab.
Here we are. Okay, Ronaldo, this is the high jump. Now explain to us how this works.
What we're going to get you to do is a test of lower body power. The higher you jump, the more powerful your legs are going to be. So
jumping ability is going to be tested.
Okay, so for headering, it's the action of either attempting to pass the ball or score the ball with your head. And in the video, it would have shown that both your lower and upper extremities are used for the action of headering the ball. The lower extremities are used for lifting the body off of the ground, of course, and the upper extremities are used for support in order to lift the body up. And the groups of muscles used in this action are gluteus maximus, quadrilaterals, calves, and hamstrings. And in the particular case of Cristiano Ronaldo, what allows him to jump a total of 78 centimeters off the ground is the fact that when he jumps, he tucks his legs up behind him, and that helps him counteract the effects of gravity. And it gives him the visual effect that he's suspended in midair, as the video would have shown. And then here is the example we recreated of Cristiano Ronaldo jumping. So he is running into a header as a teammate is sending him a center, which will be a pass sent to him in order to try to score the ball into the goal with this head. And he reaches the trajectory of the ball and he jumps to 78 centimeters off the ground. As we see over here to the right-hand side, right before he lifts himself off the ground, we did the analysis at the joint, and he generates a normal force of 4,527.65 newtons in order to lift himself off the ground. And then within his muscles, the force generated comes out to a total of 11,319.13 newtons. The resulting joint forces are 9,802 newtons in the X direction and 10,000 newtons in the Y direction. That's it. Thank you guys for your time. Thank you.
Great job, guys.
Thank you.
All right, so that's it for our presentations today. So thank you, everyone. Thank you for coming. You guys are getting a lot of encouraging messages in the chat, by the way. All right, so that's all we got time for today. And so we're going to pick it up again on Wednesday for the rest of our presentations, and then we'll go from there. So the thing I'll say for the Wednesday presentations, because we are so packed on Wednesday, is to make sure you guys are rehearsing for Wednesday. So we're gonna have just 15 minutes per group on Wednesday. So today was a little bit more relaxed because we had the time, but Wednesday is gonna be tight, and so try to keep it to 15 minutes. Okay. All right. So thank you everyone for coming. Hope you guys enjoyed the presentation today. I think both groups did a really great job today. And if you didn't fill out your SOQs yet, then please go do that. I'll send an email later tonight to remind you about that as well. Okay? All right. So I'll see everyone on Wednesday. Yeah.
Thank you, Professor.
Thank you, Professor.
Do like, you know, like this for 10 minutes.
Yeah.
Like this for 5, like 2.
Yeah, I'll help you guys keep time on Wednesday. So I'll give hand signals to help you keep time.
Because I know I could definitely talk a lot
Mhm.
for my presentation, so I just want to make sure I'm not getting like too far into the weeds.
I'll give you warnings every 10 minutes. Yeah. So today I didn't really, I mean, I took the time, but I didn't want to cut people off too much. But yeah, Wednesday we have to be a little bit more
Yeah,
strict.
'cause I know we have like what, 6 presentations
Yeah.
on Wednesday or something.
Yeah. All right, David Carlos, do you have any other questions before we sign off? Okay.